morning, guys. You just finished your bell ringer, which was talking about cosmic background radiation, how it's pretty much energy that when the Big Bang happened, that energy pretty much spilled out into what we have now, the universe. All right. So as that energy spilled out, it cooled, and now we have cosmic background radiation. So remember, that's one of the three evidences, one of the three things that scientists looked at and said, ooh, that's weird. What could make that? Well, if all the energy started at one spot and just spilled out, that would make that constant energy everywhere that we're seeing now. The other energy type, or the other evidence, was that when we look at galaxies, they're all moving away. And then the last one was, as that energy moved out, it cooled, made matter, and now the matter is clumping together. Remember, matter or anything with mass has gravity. So things will start clumping together. And that's what that W map thing is showing. Okay, that mass and the matter is clumping together. So you finish your bell ringer. We need to go into the universe and all those stars. And right at the top here, there's this spectral shift Google drawing thing. Now, if you remember, yesterday, we talked a lot about how, or not a lot, but we talked about how galaxies, when we look out into space, we know that they're moving away because when we look at them with the spectroscope, the light is shifted towards the red end. So when you open this up, it's going to make you make a copy. And this is what it's going to look like. It says, complete the chart to relate Doppler, wavelength, and color shift perceived by the observer. Draw in shifted spectral lines on the last two images. All right, so this is Earth. This is where we're standing from. This is a galaxy. And in this first one, it says that it's stationary. That galaxy isn't moving towards or away. It's just kind of moving with us, okay? So it's the standard. And when we look at that with a spectroscope, in the spectroscope, this is what we see. We see a rainbow and we see two lines. Remember, this spectrum, this color spectrum, can tell us the temperature of whatever you're looking at and the elements in it. So what it's showing you is there's two lines missing. We'll pretend that that element or those two lines missing mean that it has the element hydrogen. Okay, so there's lots of hydrogen in this galaxy. And so now what you're seeing, the arrow is showing, so this is just like the standard, this is the normal. Okay, now you see the galaxy is moving away from us. So we're gonna click there, make a copy, Control C, Control V. I'm gonna grab this, and this I'm gonna move. If it's moving away, the wavelengths you can see here are longer than the standard, the normal. So if they're longer, that means if I'm looking at, you can see there's the tiny waves here, they get a little bit bigger. If they're getting bigger, it's going to be moving. The actual line there, those two lines will be shifted down towards the red end. That's what this is showing you, okay? So the motion is away. The wavelength we see is longer. And the shift, because it's longer, look at the red waves. The red waves are longer than the purple waves, so we shift it towards the red end. It's red shifting, all right? Now we're pretending, or we're seeing that this galaxy is moving towards us. And this is actually how they figure out if something is barreling towards Earth. Like if there's an asteroid coming towards Earth, they look and see, is it red shifting or is it blue shifting? And if it's blue shifting, there's a whole section of NASA called the near space object or something like that. And they are looking specifically for anything blue shifting at us. So let's say this galaxy is coming towards us. Kind of gave away what's going to happen. You see the wavelength is much shorter than the standard. So shorter. And we're going to take this wavelength and move it down towards the purple end. We still call it blue shifting for some reason. Ew, why did only one of them? Control C, Control. That was weird. I don't know why only one of them moved, but we're gonna. Hopefully, you got both of them at once. But anyway, oh, that's so ugly. Okay, hold on. Get rid of that guy because it's jacking up the element that we have. Because there's two lines, we know it's the same element. They're the same spacing. But now it's moving towards the shorter end here because the waves are shorter. That hydrogen line that is normally would be right here in the green is now down towards the blue end. So it's blue shifting. Okay, so that's what it looks like when something is coming towards us. You might say, oh, it has this element, but that element is not where it's normally supposed to be. It's shifted down towards the blue end, which means it's coming closer. Or if you look at something and you're like, oh, it definitely has hydrogen in it, oh, but it's shifted down towards the red end, that object is moving away from us. You can still see what element it is, but you can also tell which way it's going. All right, so after you're done with that, save it, and you're good. Get out your Big Bang lab and start working on that, all right? We need to finish that today.